Okay, so we're going to do an example of vector addition where the two velocities given are not at right angles to each other. So what do you do? Okay. And what we're going to do is we're going to do vector sums, but we have to break them down into the components. What we're going to do is we're going to draw each vector. We're going to resolve it into components, and then we're going to sum up all the x, and we're going to sum up all the y, and that will give us the new vector. Chris, can you make sure he's alive? Just give him a little tap. Thank you. Okay, attention back at the board, please. Thank you. Okay, so Superman. Let's draw that vector in for Superman. Okay, so give yourself a coordinate system. And where would you write 10 degrees east of north? Where would that be? East of north. 10 degrees east of north. So which quadrant are we in? East of north. Up in here? Okay. And we need just 10 degrees. So it's going to be just a slight vector like this. So there's your 10 degrees east of north. Okay, and that is a vector of 489 kilometers per hour. Okay, so what I'm going to do is I'm just going to work with this vector here. And I'm not going to use this 10. I don't like this 10. I'm going to use its complement. I'm just going to use 80. I just find it easier because, well, 80 works better with the notes that I was given by my teacher. Do you guys remember the formulas for the x component and the y component? X would be r cos theta, and y would be r sine theta. And these formulas only work if you use the angle in standard position. You can't use the 10 for these formulas. You have to use the 80. It's always going to be an angle made with the x-axis. And if you're in 20-1, you would call these reference angles. And if you're not in 20-1, I feel bad for you because the two courses go pretty well together, Physics 20 and Math 20-1. Okay, so let's go. 489 is r. That's the hypotenuse. Remember, the velocity that they've given you here at an angle, that is the result. You're trying to break it down into the components. So 489 cos 80 and 489 sine 80. And what do we get there? .489 cos 80. Okay, 84.914. I'm just going to take some extra decimals. I know some people were asking me, like, why am I off just a little bit on my final answer? It's because you've rounded in between. So if you take about 3 decimals after it, you should always be okay. And then 489 sine 80, 481.571. So let's identify what these numbers mean. This 84, whoa, this always happens to me. This 84 here is the horizontal component of this vector. And the 481 is the vertical component of that vector. So there's the two components for Superman. Now let's do it again with the wind. Let's do it again with the wind. What's the wind doing? 314 kilometers an hour at an angle of 32 degrees north of east. So where's north of east? Similar, same quadrant, right? North of east. We can draw in the vector. It's going to be closer to the x-axis though, right? And it's going to be a little bit shorter than this vector, because this vector is at 489, so it should be longer than this one, which is at 314. And you don't have to be precise, just have to have some notion relative to each other. And the 32 degrees north of east, so you're going north of east, and this one's already in the standard position, the reference angle, so to speak. So we don't have to use the complement. We're happy with 32. Okay, so again, x will equal r cos theta, and y will equal r sine theta. Okay, so 314 cos 32, I get 266.287. And our sine theta, 314 sine 32, I get 166.395. I'll highlight them again just to demonstrate what each of them represent. The 166 is the vertical component. And the 266 is the horizontal component. And I'm just going to erase the question above so that I can add them together while keeping it on the screen. So now we're going to add the vectors. And of course, when you add vectors, you have to add like piecewise. The x dimension goes with the x dimension, and the y dimension goes with the y dimension. And the one thing about this question is the sign's not going to matter. Why? Look at the blue. Are they both in the same direction? So when we add them, it'll be a positive plus a positive. What if the wind was blowing west? When you add the blues, you would have to account for the negativity. Okay, so this one worked out nice because everything's in the same direction. It's east, it's north, it's north. So when we add the displacements, east plus east is more east, right? And north plus north is more north. Okay, so let's take a look at what this would look like. Here's the first vector of Superman flying. Change color. Use purple. Here's the vector for the wind. So what actually happens? The green. The green is what actually happens, and I'll zoom in here a bit. So I'll use my pointer. So see this over and this up? That's here. Over and then up. That's from this. And then this blue over and this up is from this over and up. So it's just a sum of the x's, a sum of the y's for this new vector, which is green. So Superman's flying off like this, the wind is pushing like this, and what actually happens to Superman is this green thing. And you notice that triangle, is it right angled? No, so you can't just use like sine, cosine, tan of a right angled triangle like you've been taught since grade 10. Say that again? You could use sine law or cosine law, yeah. A lot of students in here have no idea what that is though, because they haven't taken 20-1 yet. Okay, so let's put in Let's put in our numbers. Let's add the blue. Add the blue. You did it for me? Okay, I'm just going to do it just in case we make a mistake, and then I got to go back, and that'll be annoying. 266.287. Did you get 351.201? And then let's add the red. 481.571 plus 166.395. 647.966. So these numbers I'll highlight in green. The 351 is the X, that's this, and the 647 is the vertical. So this is the 351, this is the 647. Now that we have the X and the Y component for this new result R, we can now solve for the resulting in green in R here. And now it's back to some basic stuff, because now it's a right angled triangle here with these new components. Yeah, like I just rounded, Elgin. Just got lazy. Okay, so this 351.201, we'll square it and add it up with the Y, which is 647.966. So I got 737.022 kilometers per hour, and the theta, second function tangent of the y over the x, the 647 over 351.201. Now this style of vector sum is quite rare for Physics 20. It might happen a little bit in the dynamics. This is more for Physics 30. Okay, so I'm showing it to you once now so you see it. We may see it in dynamics. Okay, and then what were the sig digs of the question? 3 sig digs? In the question it looked like 2 from the angles, right? So 62 degrees. And what's this direction? North of east. And this 737, we can say it's 7.4 times 10 to the 2. The unit is km per hour. Okay, and then let's just write it out formally. VR is equal to 7.4 times 10 to the 2 kilometers per hour, comma, 62 degrees north of east. That's a lot, right? There's a lot going on there. Okay? So this is, for any vectors, you could have like 7 or 8 vectors if you wanted, 10 vectors. You could still do this. Get all the x's, get all the y's, add it up together. The only one thing I don't like about this question was everything was in the same direction, right? So you didn't have to subtract or add negatives. So imagine if Superman was flying this vector, but the wind was blowing like southeast, right? So when you add the y components, you would, it slows him down. So the direction he's flying would be positive and the wind would be negative in the y only, and you would have to take that into account. Just like you would do in Science 10 with displacement, north plus a south is a positive plus a negative. Okay, so in your workbook, cancel workbook. I think it's like 4.5-ish. page 135. Page 135. You can read this example here, question 1. Notice how they split. Okay, they're going to do the sum on x over here. They're going to do the sum of y over here. Okay? And it's about a Canadian moose, so that's awesome. Take a look at these two displacements. Look at these two displacements. Displacement 1, does it have any y in it? Or is it only left and right? It's only one dimensional. But displacement 2 has the 2 dimensions, right? Which way is displacement 2 going? It goes east and south. So look in the example where they summed up the y's. What did they do? They put on the direction, right? So you got to be very mindful of direction. Okay? So you're going to read that example 1, and you're going to try problem 1 and problem 2, and problem 3. And I don't really like problem 4 because it gives you bearings. So if you want, you could try it as a challenge, but if you could get 1 to 3 done, and 5. Nope, it has bearings. So let's go 1 to 3. And again, I'm keeping it minimal because there's not a lot of this in Physics 20. I just want you to see it so that when you get to Physics 30, it's not a shock.